Hello everyone, Najah here. This video is about my research study of nature-inspired wind energy harvesting based on piezoelectricity for sensing applications. Enjoy the video!
Wind energy is one of the main renewable energy resources harvested from the nature other than solar, hydro, tide, and geothermal. Countries that have consistent windy environment with annual average wind speed at least 2 meters per second are suitable for wind turbine installation for large-scale energy production. However, Malaysia has lower than 2 meters per second average wind speed annually, which make it insufficient to initiate wind turbine rotation and impractical to generate energy from the conventional wind farm. This research provides a solution to this problem where we can still take advantage of the wind flow by using small-scale wind energy harvesting for sensor applications that only need small electricity to power up themselves, such as motion sensor and light sensor. Small-scale wind energy harvesting has been widely researched, but current designs face constraints in power output and efforts are needed to increase the efficiency of these systems, optimizing their ability to harvest more energy from the wind. The objectives of this study are to develop and optimize the design of wind energy harvesting systems that mimic the motion of leaves in the wind to generate power for small sensors and wireless communication devices. Second is to investigate the feasibility and sustainability of using nature-inspired wind energy harvesting systems as a potential alternative to batteries for small-scale applications. This research is built upon the utilization of the piezoelectric effect mechanism, which enables the conversion of mechanical stress into electricity. This research prototype draws inspiration from the intricate structure of leaves. I replicated the leaf's design to emulate its natural motion. The prototype, created using Tinkercad and produced by a 3D printer, incorporates Python programming, a Raspberry Pi Pico, and an amplifier module. The experiment involves using a hand fan as a wind source to achieve a wind speed of 3.0 meters per second. My focus in this research is on optimization. The first optimization involves the positioning of the piezoelectric film on the primary cantilever at points A, B, and C. After experimentation, it was found that position C yields the highest voltage at 46.73 mV, making it the optimal location for the second phase of optimization. The second optimization explores the width of the secondary cantilever, varying it from no secondary cantilever to widths of 10 mm, 20 mm, 30 mm, and 40 mm. As expected, the wider the surface, the more efficiently wind energy is captured and converted. Moving on to the third optimization, the length of the secondary cantilever is tested at the most efficient width 40 mm, lengths of 100 mm, 110 mm, 120 mm, 130 mm, and 140 mm were examined, with the surprising result that the most efficient length was 130 mm, producing 0.15 volt. The decrease in results for the 140 mm length may be attributed to increased weight. In conclusion, we have developed a nature-inspired wind energy harvesting system that generates electricity. The optimal configuration features a 40 mm x 130 mm secondary cantilever with a piezoelectric film positioned at point C on the primary cantilever. This configuration successfully meets the research objectives, demonstrating the effectiveness of wind energy harvesting systems inspired by the motion of leaves and has improvement from past research. Taking the research further into phases like storing voltage in capacitors or directly activating sensors could result in effective and environmentally friendly systems. This approach addresses the limitations of conventional battery-powered sensing devices, including limited lifespan, frequent replacements, and environmental concerns. Moreover, it offers a cost-effective alternative to users compared to current conventional batteries. This aligns with the seventh goal of the Sustainable Development, emphasizing the commitment to ensuring affordable and clean energy access for all.